Hello, my name is Janet, and not long ago I remembered that I really like calculus. I haven't thought about math for a while. I haven't done any math for months, but I saw this post on Instagram about a calculus textbook called Calculus Made Easy by Sylvanus Thompson, where the author, Sylvanus Thompson, starts his book off with this quote, "What one fool can do, another can." And I thought it was absolutely hilarious. And I started reading the book, like chapter 1, chapter 2, and I was like, oh my goodness. Number 1, this makes so much sense. Number 2, I am enjoying this. I am enjoying reading a calculus textbook. And so suddenly I remembered how much I loved calculus. It was the first math class that made me really think like I actually like math in general, because up until calculus, math was just memorization of formulas, of, formulas and exams. That's it. And there's no fun in that. But when we got to a point where there had to be some sort of understanding rather than just memorization, suddenly I found it such a wonderful game to play, where things connect with each other and it's so much fun to figure out what the connections are. And so now that I have magically out of nowhere remembered that I like math, I want to explore it. I have already graduated college. I have my bachelor's degree. And in college and in any sort of education system, well, not any education system, but in the majority of the education systems that we have in the world, when you go to college or high school or anything, you have grades, you have exams, you have tests, and you have deadlines. And that's not the best way to explore something and really be curious about it. And so now that I don't have to do anything for school in terms of like assignments, now that I'm not being graded, now that I don't have to learn a specific topic by a specific date, I am free to explore however I want. And that is a very, very wonderful freedom. And so what I want to explore is math. And I guess I don't really know someone in the moment, in like my current moment, like literally right now. I don't really know someone who would do this with me, who would explore math, at my pace, at their pace, at our own pace, without having a specific lesson that we have to complete, without having homework, without anything, any particular pressures. Just exploring because we want to explore any topic that we want to explore in whatever order we want to explore it in. And so my current solution to this is I'm just going to make some videos where I talk to myself, maybe to you, whoever you are, if anyone actually ever watches this. And I'm just going to explore math. I have no particular path that I'm trying to get to. My goal, my personal goal, is to get to a point where I don't understand maybe a specific topic or something, but that I understand the connections that exist between different formulas or different types of math, because they're separated into different topics, and to throw away all those separations, to explore as I wish, and to have a good time. And so if you are watching this and you like math, I invite you to join me as I try to remember even more why I think math is so amazing, and while I try to have fun exploring and understanding the amazement that it is. And so, I have my cup of tea, I have my computer, I have a pencil, my notebook, and that's it. You don't really need anything. You can grab a cup of tea if you like. I'm not trying to make any sort of, super engaging type videos. So, just to hang out while I figure out math. So I think one of the first things that I'm going to do is read this article that's called A Mathematician's Lament by Paul Lockhart. One of my professors at university sent this article to me one day. He said, "I think you'd like it." And I don't think I've ever finished reading the entire thing, but I started it, and I remember that when I did, it gave me such a good sense of what math really is. How math is not memorization, and math is most definitely not doing what you are told. And so, I don't actually remember exactly what the article says, and I hope that in reading it I will remember again. And maybe it'll help you know what math really is. So here we go. A Mathematician's Lament by Paul Lockhart. A musician wakes up from a terrible nightmare. In his dream, he finds himself in a society where music education has been made mandatory. We are helping our students become more competitive in an increasingly sound-filled world. Educators, school systems, and the state are put in charge of this vital project. Studies are commissioned, committees are formed, and decisions are made, all without the advice or participation of a single working musician or composer. Since musicians are known to set down their ideas in the form of sheet music, these curious black dots and lines must constitute the language of music. It is imperative that students become fluent in this language if they are to attain any degree of musical competence. Indeed, it would be ludicrous to expect a child to sing a song or play an instrument without having a thorough grounding in music notation and theory. Playing and listening to music, let alone composing an original piece, are considered very advanced topics and are generally put off until college and more often graduate school. As for primary and secondary schools, their mission is to train students to use this language to jiggle symbols around according to a set of fixed rules. Music class is where we take out our staff paper, our teacher puts some notes on the board, and we copy them or transpose them into a different key. We have to make sure to get the clefs and key signatures right, and our teacher is very picky about making sure we fill in our quarter notes completely. One time we had a chromatic scale problem, and I did it right, but the teacher gave me no credit because I had the stems pointing the wrong way. In their wisdom, educators soon realize that even very young children can be given this kind of musical instruction. In fact, it is considered quite shameful if one's third grader hasn't completely memorized his circle of fifths. I'll have to get my son a music tutor. He simply won't apply himself to his music homework. He says it's boring. He just sits there staring out the window, humming tunes to himself and making up silly songs. In the higher grades, the pressure is really on. After all, the students must be prepared for the standardized tests and college admissions exams, students must take courses in scales and modes, meter, harmony, and counterpoint. It's a lot for them to learn, but later in college, when they finally get to hear all of the stuff, they'll really appreciate all the work they did in high school. Of course, not many students actually go on to concentrate in music, so only a few will ever get to hear the sounds that the black dots represent. Nevertheless, it is important that every member of society is able to recognize a modulation or a fugal passage, regardless of the fact that they will never hear one. To tell you the truth, most students just aren't very good at music. They are bored in class, their skills are terrible, and their homework is barely legible. Most of them couldn't care less about how important music is in today's world. They just want to take up the minimum number of music courses and be done with it. I guess there are just music people and non-music people. I had this one kid though. Man, she was sensational. Her sheets were impeccable, every note in the right place, perfect calligraphy, sharps, flats, just beautiful. She is going to make one hell of a musician someday. Waking up in a cold sweat, the musician realizes gratefully that this was all just a crazy dream. Of course, he reassures himself, no society would ever reduce such a beautiful and meaningful art form to something so mindless and trivial. No culture could ever be so cruel to its children as to deprive them of such a natural, satisfying means of human expression. How absurd. Meanwhile, on the other side of town, a painter has just awakened from a similar nightmare. I was surprised to find myself in a regular school classroom. No easels, no tubes of paint. Oh, we don't actually apply paint until high school, I was told by the students. In 7th grade, we mostly study colors and applicators. They showed me a worksheet. On one side were swatches of color with blank spaces next to them. They were told to write in the names. I like painting, one of them remarked. They tell me what to do and I do it. It's easy. After class, I spoke with the teacher. So, your students don't actually do any painting? I asked. Well, next year they take pre-paint by numbers. That prepares them for the main paint by numbers sequence in high school. So they'll get to use what they've learned here and apply it to real-life painting situations, dipping the brush into paint, wiping it off, stuff like that. Of course, we track our students by ability. The really excellent painters, the ones who know their colors and brushes backwards and forwards, they get to the actual painting a little sooner, and some of them even take the advanced placement classes for college credit. But mostly, we're just trying to give these kids a good foundation in what painting is all about, so when they get out there in the real world and paint their kitchen, they don't make a total mess of it. These high school classes you mentioned, you mean paint by numbers? We've been seeing much higher enrollments lately. I think it's mostly coming from parents wanting to make sure their kid gets into a good college. Nothing looks better than advanced paint by numbers on a high school transcript. Why do colleges care if you can fill in numbered regions with the corresponding color? Oh, well, it shows clear-headed logical thinking. And of course, if a student is planning to major in one of the visual sciences, like fashion or interior decorating, then it's really a good idea to get your painting requirements out of the way in high school. I see. And when do students get to paint freely on a blank canvas. You sound like one of my professors. They were always going on about expressing yourself and your feelings and things like that, really way out their abstract stuff. I've got a degree in painting myself, but I've never really worked much with blank canvases. I just use the paint by numbers kits supplied by the school board. Oh, I love this article. Sadly, our present system of mathematics education is precisely this kind of nightmare. In fact, if I had to design a mechanism for the express purpose of destroying a child's natural curiosity and love of pattern making, I couldn't possibly do as good a job as is currently being done. I simply wouldn't have the imagination to come up with this kind of senseless, soul-crushing ideas that constitute contemporary mathematics education. Everyone knows that something is wrong. The politicians say, we need higher standards. The schools say, we need more money and equipment. Educators say one thing, and teachers say another. They are all wrong. The only people who understand what is going on are the ones most often blamed and least often heard, the students. They say, math class is stupid and boring, and they are right. Mathematics and culture. The first thing to understand is that mathematics is an art. The difference between math and other arts, such as painting and music, is that our culture does not recognize it as such. Everyone understands that poets, painters, and musicians create works of art and are expressing themselves in word, image, and sound. In fact, our society is rather generous when it comes to creative expression. Architects, chefs, and even television directors are considered to be working artists. So, why not mathematicians? Part of the problem is that nobody has the faintest idea what it is that mathematicians do. The common perception seems to be that mathematicians are somehow connected with science. Perhaps they help the scientists with their formulas, or feed big numbers into computers for some reason or other. There is no question that if the world had to be divided into the poetic dreamers and the rational thinkers, most people would place mathematicians in the latter category. Nevertheless, the fact is, there is nothing as dreamy and poetic, nothing as radical, subversive, and psychedelic as mathematics. It is every bit as mind-blowing as cosmology or physics. Mathematicians conceived of black holes long before astronomers actually found any, and allows more freedom and expression than poetry, art, or music, which depend heavily on the properties of the physical universe. Mathematics is the purest of the arts, as well as the most misunderstood. So let me try to explain what mathematics is and what mathematicians do. I can hardly do better than to begin with G.H. Hardy's excellent description. A mathematician, like a painter or a poet, is a maker of patterns. If his patterns are more permanent than theirs, it is because they are made with ideas. So, mathematicians sit around making patterns of ideas. What sort of patterns? What sort of ideas? Ideas about the rhinoceros, No, we leave those to the biologists. Ideas about language and culture? No, not usually. These things are all far too complicated for most mathematicians' taste. If there is anything like a unifying aesthetic principle in mathematics, it is this: simple is beautiful. Mathematicians enjoy thinking about the simplest possible things, and the simplest possible things are imaginary. For example, if I am in the mood to think about shapes, and I often am, I might imagine a triangle inside of a rectangular box. I wonder how much of the box the triangle takes up. 2/3 maybe? The important thing to understand is that I'm not talking about this drawing of a triangle in a box, nor am I talking about some metal triangle forming part of a grider system for a bridge. There's no ulterior practical purpose here. I'm just playing. That's what math is. Wondering, playing, amusing yourself with your imagination. For one thing, the question of how much of the box the triangle takes up doesn't even make any sense for real physical objects. Even the most carefully made physical triangle is still a hopelessly complicated collection of jiggling atoms. It changes its size from one minute to the next. That is, unless you want to talk about some sort of approximate measurements. Well, that's where the aesthetic comes in. It's just not simple, and consequently it is an ugly question which depends on all sorts of real-world details. Let's leave that to the scientists. A mathematical question is about an imaginary triangle inside an imaginary box. The edges are perfect because I want them to be. That is the sort of object I prefer to think about. There's a major theme in mathematics. Things are what you want them to be. You have endless choices. There is no reality to get in your way. On one hand, once you have made your choices, for example, I might choose to make my triangle symmetrical or not, then your creations do what they do, whether you like it or not. This is the amazing thing about making imaginary patterns. They talk back. The triangle takes up a certain amount of its box, and I don't have any control over what that amount is. There is a number out there. Maybe it's 2/3, maybe it isn't. But I don't get to say what it is. I have to find out what it is. So we get to play and imagine whatever we want, and make patterns and ask questions about them. But how do we answer these questions? It's not at all like science. There's no experiment I can do with test tubes and equipment and whatnot that will tell me the truth about a figment of my imagination. The only way to get the truth about our imaginations is to use our imaginations, and that is hard work. In the case of the triangle in its box, I do see something simple and pretty. If I chop the rectangle into 2 pieces like this, I can see that each piece is cut diagonally in half by the sides of the triangle, so there's just as much space inside the triangle as outside. That means the triangle must take up exactly half of the box. This is what a piece of mathematics looks and feels like. That little narrative is an example of the mathematician's art, asking simple and elegant questions about our imaginary creations and crafting satisfying and beautiful explanations. There is really nothing else quite like this. Quite like this realm of pure idea. It's fascinating, it's fun, and it's free. Now, where did this idea of mine come from? How did I know to draw that line? How does a painter know where to put his brush? Inspiration, experience, trial and error, dumb luck. That's the art of it. Creating these beautiful poems of thoughts, these sonnets of pure reason. There is something so wonderfully transformational about this art form. The relationship between the triangle and the rectangle was a mystery, and then one little line made it obvious. I couldn't see, and then all of a sudden I could. Somehow, I was able to create a profound, simple beauty out of nothing, and change myself in the process. Isn't that what art is all about? That's why it is so heartbreaking to see what is being done to mathematics in school. This rich and fascinating adventure of the imagination has been reduced to a sterile set of facts to be memorized and procedures to be followed, in place of a simple and natural question about shapes and a creative and rewarding process of invention and discovery. Students are treated to this triangle area formula. Area equals 1/2 base times height. The area of a triangle is equal to 1/2 of its base times its height. Students are asked to memorize this formula and then apply it over and over in the exercises. Gone is the thrill, the joy, even the pain and frustration of the creative act. There is not even a problem anymore. The question has been asked and answered at the same time. There is nothing left for the student to do. Now let me be clear about what I'm objecting to. It's not about formulas or memorizing interesting facts. That's fine in context and has its place just as learning vocabulary does. It helps you to create richer, more nuanced work of art. But it's not the fact that triangles take up half their box that matters. What matters is the beautiful idea of chopping it with a line and how that might inspire other beautiful ideas and lead to creative breakthroughs in other problems, something a mere statement or fact can never give you. Okay, I really like where I am, and I'm starting to remember. The main point, that math is an art. Math is an art of patterns, and it's about playing and exploration. That's what I want it to be about. That's what I want to feel. It's something that I definitely didn't get in school, and that I really, really want to feel and enjoy. And the most amazing thing is thinking about how math really is not bounded by the physical world. It is imagination. It's a game of the imagination. And so I think that's really amazing. And so my voice is getting tired of reading, so I'm going to stop here for part 1 and continue later. But by then, there will be more tea, and I will be ready to read again and continue. I'm excited to see where this goes. I really hope that I can find a path that will be me following curiosity and creativity about math. So, yeah, this is part 1. It's mostly for me, but if you see it, I'm glad that you do. I will put the link to this article that I'm reading in the description in case you would like to see it, in case you just want to read it yourself without me reading it. But I think this is the most important place to start before actually doing some math, is getting across the idea about what math is and what I want it to feel like. So this is the best article that I can possibly think of to do that. So thank you for joining me. We shall see how this goes, if I actually continue making these videos or if I just find some random time in my week to read math, to do math, to play with math. So we'll see. Thank you. Bye for now.